Okay, sorry I'm not with you today, but I can take you through the work that I'd planned. And we were going to work on a topic called trial and improvement, which is a grade C topic. Okay, so long as you follow the steps, this is relatively straightforward work. And it'll always be on the paper too, the non-calculated paper. So all the work we've done on solving equations up until yesterday, we were able to use algebra to find a solution. So if it's something like 2x minus 3 equals 7, we could rearrange that to get x equals whatever the value is. Yesterday we looked at graphical solutions for equations where we couldn't solve them, and we practiced that. The other method of solving for equations that there's no algebraic method is trial and improvement. And this is basically a decimal search that we look in order to zoom in, to home in on our solution. So let's take a look at this one. So solution of the equation x cubed minus 13x equals 107 lies between 5 and 6. Use the method of trial and improvement to find this solution correct to one decimal place. So there's no algebra we can use here. We have to use this trial and improvement method. You must show all your work. So what we are looking for is the value to one decimal place that's between 5 and 6, which is going to make x cubed minus 13x close to 107. Okay? And if you think about this, so I know my answer is between 5 and 6. So that would be 5.0 to one decimal place. And then if I just tick these off, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that one would be 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, 5.9, 6.0. One of those numbers is going to be my answer. And all I have to do now is search to find which one it is. And the way we do it is we want to eliminate as many potential answers as possible every time we search. So we go halfway. So I'm going to try x is 5.5. And my formula, my equation, is x cubed minus 13x equals 107. So I'm going to replace the x with 5.5. Okay? And if you think that the way that I write an x is like two round brackets, but the wrong way around. So if I need to replace that x, I'm going to smash it open and it becomes brackets that way. So when I'm replacing the x, I'm going to have 5.5 minus 13 bracket 5.5. So all I've done is I've replaced the x with 5.5. Now on your calculator, we type that in, sorry, it's 5.5 cubed, isn't it? 5.5 cubed minus 13. So on your calculator, open bracket, 5.5, close bracket. Now the cube button is above the x squared, so shift x squared gives me the cube, and then minus 13 bracket 5.5. So I've typed it in exactly as I've written it, and then I work out what the answer is, and I write that down. 94.875. Now what I do is compare what that produces with my target. So my target is 107, so that's too small. So I write that down. And if 5.5 gives me an answer that's too small, everything lower than 5.5 will also give me an answer that's too small. So I can disregard all the values of x between 5.0 and 5.5. So now I go again. So I want to go somewhere now between 5.5 and 6. And I'm only working to one decimal place. So I'm going to go 5.7, I think. So I'm going to write that down. Try x equals 5.7. 5.7 cubed minus 13, 5.7 equals. So we go back to our calculator. We don't have to type that again because we can use the cursor keys to move ourselves back up through the equation. So I'm going to change that to 5.7. And I'm going to change that to 5.7. And that's 111.093. I'm looking for 107, so that's too large. Which means everything greater than 5.7 is also too large. So I can take out that. And I keep going now until I've got my answer between two consecutive one decimal place number. And I haven't at the moment because there are two consecutive decimal place numbers. So I'm going to try 5.6 next. 5.6 cubed minus 13 5.6 equals, back on my calculator, back up and change that to a 6 and that to a 6, and that's 102.816, which is too small. Which means everything less than 5.6 is too small. Which means one of these is going to be my solution. My solution lies between 5.6 and 5.7. So what we have to do now to decide which one it is we have to go halfway between them. So if I just redraw my number line, and now my number line is, I know that that is 5.6 and I know that that is 5.7. So I now try halfway between. Now I have to go to two decimal places, and halfway between is 5.65. So try x equals 5.65. 5.65 cubed minus 13 5.65 equals, back up to my formula, stick a 5 in there, and a 5 in there, and it's 106.9, which is too small. And if that is too small, everything between 5.65 is too small. And everything that is between 5.65 and 5.7 rounds up to one decimal place to 5.7. So that is too small. All values between 5.65 and 5.7 round to 5.7 to one decimal place. So 5.66 would round to 5.7 and so on. So therefore x equals 5.7 to one decimal place. Okay, and that's the method. So there's 4 marks for that. The way the 4 marks are awarded is you get a method mark if you've correctly substituted any value between 5 and 6 into that formula. So that top line there will give you a method mark. You'd get an accuracy mark, the second mark, once you've managed to bring it down to 2 consecutive one decimal place numbers. So the second mark is for getting it between 5.6 and 5.7. Then to get the final 2 marks, you have to do this final part where you go to 2 decimal places and then work out from that whether it's too big or too small. And those are the 4 marks. They're really straightforward so long as you've got your calculator with you, okay? Which clearly you will in the exam. I hope you've remembered today. I did ask you yesterday to bring your calculators today. So that's what you need to do. If we quickly have a look at the questions then that you can work through. So a solution to the equation x cubed minus x minus 5 equals 0 lies between 1 and 2. Find the solution correct to one decimal place. So your number line is going to go between 1.0 and 2.0, and you're going to count up in 1 decimal places, so 1.1, 1.2, 1.3, and then conduct your search. Same with this one. This one lies between 2 and 3. Solution to 1 decimal place. So your number line is going to start at 2.0 and count up in 1 decimal point places to 3.0. So 2.1, 2.2, 2.3. Start in the middle. See where you search. Same for that one. With this one, it's the same thing you have to do, but this time you want your solution to 2 decimal places. So what we've got here is the solution they're telling you lies between 1.8 and 1.9. So if I just get you started on that. So that's 1.80, 1.90, and then between the 2 decimal places you'll have 1.81, 1.82, 1.83, 1.84, and so on. Probably need to make it a little bit bigger. And you're searching, and when you get it between 2 of those, you then have to go to 3 decimal places in order to test. And then the final question. You have to form the equation. So the length of the rectangle below is 2 centimeters longer than the width. So if the width is x, then the length would be 2 centimeters longer than that, which would be x plus 2. And they're telling you that the area is 70. So the way you work out an area of a rectangle is multiply the length by the width. So this is telling you that x times x plus 2 equals 70. So x squared plus 2x equals 70. So that's the equation that you're then going to search through. But in this case it doesn't tell you what you're starting with. So you've got to decide where you're trying. So if you're going to try x is 5, then that will be 5 times 7, which would be 35, which is too small. So you have to keep searching for 1 decimal place and then go from there. So that one's a little bit more challenging. But hopefully all the answers there. Hopefully you can give those a good go. And I will see you next week.